Hi there. Well, we're going to be looking at section 11.2, and it deals with the quadratic formula. Now, the nice thing about the quadratic formula, and maybe some of you have seen it and used it before, some of you may not, but the nice thing about the quadratic formula is it can be used to solve any quadratic equation. And remember that a quadratic equation is anything that has a squared as its highest power. So we do need to have the squared as its highest power in order to use the quadratic formula. So if the highest power is to the third, to the fourth, fifth, sixth, no. We have to do some other things, maybe some substitution stuff, which we'll talk about. So if you're given a quadratic equation, you can use the quadratic formula to solve it. Now the last section, 10.1, we looked at, 11.1, we looked at using our completing the square method, and completing the square can get a little tedious. And especially if you have this leading coefficient right here, as other than a 1, you've got a 2. So it can be done. But in a case like this, you can't, it's obviously, well, you could factor this one, but if you've got a leading coefficient, a lot of times it's much easier to use the quadratic formula rather than to go through all of this fraction work, all right? So, like I say, you can always complete the square if that's a method that you really like, but it's not necessary. The quadratic formula can be very handy. So we're going to go ahead and we're going to look at the quadratic formula. Now I've got 2 of them here. The first one is, it's a little bit easier to memorize. Okay, this one's a little bit easier to memorize. This one right here could be used if you have an imaginary number. So if you do end up with an imaginary here, if you end up with a complex number, a lot of times they want you to split the real, which will be this first part, from the imaginary and put it into 2 different parts. So again, usually when we have a common denominator, okay, we can put it under the same denominator and add or subtract our numerators, which is what we're doing. So these 2 really mean the same thing, just written differently. Okay, and we'll use both of those. And so you can get used to looking at both of these. But I always start with this one. I always start with this one. All right. So in this formula, this quadratic formula, the A, if you look here, the A in the formula is the number in front of your x squared. The B in the formula is the number in front of the x. So when we're filling this in, we're not going to be putting the x's in. These represent the numbers in front of the x squared, the numbers in front of the x to the first, and then your c is your constant. So don't put the x's, don't include x squared with the a. So when we're talking about the a in the formula, it's just the number in front. Here, when we're talking about the b in our formula, it's just the number in front. So don't try to put the x into the formula, because then you have a nightmare. We don't want that. Okay, well, let's go ahead and we're going to practice the quadratic formula. It's the only thing we're going to do today, which is kind of nice. Maybe I can keep this under an hour. I'll try. I really do try most of the time to keep it down. It just, I don't know. Time gets away from me. Now, this is not like completing the square. When you're using the quadratic formula, you're back to getting a 0 on one side. So we're back to that idea instead of completing the square where we would move the number over. So here we do have to bring that -3 over to the left-hand side to be with the 5x squared and the 8x. So I'm going to add 3 to both sides. So I've got 5x squared plus 8x plus 3 equals 0. So I added a +3 to both sides. So once you've done that, you're ready to fill in the formula. We're going to have some problems where you might be able to reduce these 3. They may have a greatest common factor, and you can do that. You don't have to. It just means that you're dealing with larger numbers and you may have to reduce your answer more. And so a lot of times it's nice to take out something in common if you can. All right, but in this case, there's nothing. So we're going to fill in our formula. And I highly recommend that you do memorize this formula. I know that you're being online now, that, you can just have it sitting right there, which is fine, but eventually I would memorize this formula. Because if you have an equation, a quadratic equation, that's difficult to factor, it may not be easy to complete the square, you can always use your quadratic formula. On this note, you can always use this method whenever you have a squared in your equation. So let's go ahead and fill in our equation. I'm going to go ahead and rewrite it here, a minus b. What that actually means, whenever you have a negative in front of a variable like that, it just means take the opposite of the b. So our first step will be to take the opposite of the b, plus or minus the square root of b squared minus 4ac all over 2a. And just don't forget the 2a. Okay. Alrighty. So again, let's go through this. Our a, I'm going to write the a in the formula is 5. I'm going to write this on the side here. B in our formula is the 8. It's the number in front of the x term. Our c is our constant, 3. Alrighty. So now that we have our a, b, and c, we're going to go ahead and plug them into the formula and reduce the formula. So here we'll have the opposite of the b, which will be a negative 8. Okay, we took the opposite of b, so it's a negative 8. Plus or minus, we're going to square the b. So we're going to take the 8 and square it. Okay. Then we have a subtraction symbol. The subtraction is part of the formula. 4 is part of the formula. A is 5. So I have 4 times our a is 5 times our c, which is 3. All over 2. 2 is part of the formula. A is 5. So all we need to do now is reduce this. Now you have to be careful. Inside, we're going to do inside the radical first. And inside the radical, you need to remember that you don't take the 64, which is what 8 squared is. Don't subtract the 4 and separate, because remember in PEMDAS, you do your exponents, and then you have to multiply these 3 before you subtract. All right, so, and and some of you, especially if you have a calculator that has the that'll show you what exactly you're doing. It'll have that readout. You could write 8 squared, subtract. You could put in 4 times 5 times 3. All right, and it'll tell you what this number is inside. So we'll need to find out what that is. Here we have a minus 8 plus or minus 64 is 8 squared, subtract 4 times 5 is 20 times 3 is 60. 2 times 5 is 10. All right. So now then we'll go ahead and we'll take 64 minus 60. And again, if you have a calculator, you could just type it in without the radical. Don't put the radical in right now. Just find out what that inside is equal to, and then we'll reduce it. So we have a minus 8 plus or minus the square root of 4. All right, so again, 64 minus 60 is 4. If you put the radical in and you ended up with a negative inside, your calculator will give you an error message. But we're working in the complex number system, so you can't have the error. So if you just go ahead and find this number without your radical, just go ahead and type in 8 squared minus 4 times 5 times 3 and come up with this. If it's a negative, you know to bring out an I, all right? Otherwise, your calculator will give you an error. So now we just need to reduce. I've got a minus 8 plus or minus 2. So I just found out what the square root of 4 is, which is 2. Okay, what do you do here? Well, you've got some options. You could divide, okay, 2 goes into all 3 of these. So if you have a number that will go into all 3 of them, you can go ahead and do that and work with smaller numbers. Now that's one way. The other is to go back to this part right here. You could put -8 over 10 plus or minus 2 over 10. Okay, that's another way of doing it. So unfortunately, sometimes it's harder when you have a bunch of options because you have to decide. Another way, because you don't have a radical here, is you can take a -8 plus 2 divided by 10, a -8 minus 2 divided by 10. What I'm going to do is I'm going to reduce. So I'm going to divide each of these by 2. Okay. And again, you don't have to do this. You could either reduce now or reduce at the end. Now, I know I have these two solutions. This is a -4 plus 1 over 5, or a -4 minus 1 over 5. So I split those into these two. Okay, so I did reduce. Now you don't have to do that. You could have done, it froze, there we go. You could have taken -8 plus 2 over 10, -8 minus 2 over 10. You could have used those instead of these right here. Either way, you'll come up with the same answer. This gives me -3/5 as an answer, and a -5 over 5, which is a -1. Okay. Those are your two solutions. All righty. So again, you can, because our radical disappeared, we were able to go ahead and take a -8 plus 2 over 10, okay, -8 minus 2 over 10. Unless, of course, you divided each one of these by something that would go into all 3 of them. Sometimes there is nothing that will go into all 3 of them, but in this case, it was a 2. So I took a -4 plus 1 over 5 and a -4 minus 1 over 5, and then reduce those. Okay. Well, again, this is all we're going to do, and so we're going to keep practicing. And sometimes maybe at the end, it's it's where do you stop? What do you do when you get to this point? But I'm hoping it doesn't give you too much trouble. But let's go ahead and practice some more. Let's look at this one right here. Again, even though there are some of these you say, well, I could factor this maybe faster, we're still going to use the quadratic formula because I want you to practice it. Okay, we need to set it equal to 0. So what I'm going to do is I'm going to bring the 18x over and the 6 over. So I'm going to have 3x squared minus 18x when I bring it over, and a positive 6. And then I have a 0 on the right-hand side. So I subtracted 18x and I added 6. There's not a lot of room in there, sorry, to both sides. Okay, now, if you look at this, you're thinking, okay, you could just start in with the quadratic formula using 3, 18, and 6. Or you could say they have, there's something that goes into all 3 of these. And you could do that. You could take that number and divide each of these by 3. Okay? Because it's an equation, you don't necessarily have to factor it out. You could divide everything by 3 here, or factor out a 3. Either way, maybe I'll go ahead and just factor out a 3 rather than divide them all by 3. I don't want you guys to get confused in case there's an x. The x you'd have to keep outside. So we'll have 3x squared. And again, multiply to come back. 6x. 6 and 3 is 18 plus 2. Okay. And again, we know we're only going to have the 2 solutions. This 3 really plays no part in the solutions because there's not a variable out there with it. In order for it to have been a part of the solution, you would have needed to have an x. And then you know then that one of your solutions would be 0. Okay, so what we're going to do, because I factored out this 3, okay, it changed my coefficients. So it made them smaller. So in other words, now my a is 1. It's a 1 in front of the x squared. B is a negative 6 in front of the x. C is a positive 2. Now again, if you would have used A is 3, B a negative 18, and C is 6, you'll come up with the same answer, just bigger numbers that you have to work with. But I'd encourage you to look for something to take out, if possible. And then that way you have smaller coefficients to deal with. Well, let's go ahead and let's fill in our quadratic formula. I will kind of, there, kind of create a border there for us. Okay, we'll have x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So we start with our formula. We'll take the opposite of the b. That's what that negative is. It's the opposite of the b, so it's going to be a positive 6. Okay, so I start out with a positive 6. So again, don't forget to take the opposite of the b every single time. So then I have my plus or minus, square root. Okay, I'm going to square my b. Well, when I square the b, you know, even though it's negative, when you square something, it becomes positive. So if you substitute that negative in, okay, if you want to use your negative, and that's fine, that's great. Make sure you use parentheses when you square it, and the square needs to go outside of the parentheses. Or, you know, and some of you will probably just do that in your head and say, okay, 36. You won't even write this down. So then we have subtract 4, part of the formula, so is the subtraction. The a is 1, and the c is 2. All over, don't forget your 2 times your a. All right, there's your quadratic formula. That is your answer, but it needs to be simplified. So these are these are the solutions to this equation. So we're going to go ahead and simplify. I know this is positive 36. Negative 4 times 1 is 4 times 2 is 8. 2 times 1 is 2. So we end up with 6 plus or minus the square root. 36 minus 8 gives us 28. Okay, so far so good. So now then, this one, you see above, we got rid of our radical because the square root of 4 was 2. Unfortunately, when I reduce this, I'm going to be left with a radical. So go ahead and reduce this if you can. I'm not saying you'll always be able to take something out of this radical, but in this case we can. So what I'm going to do is might run out of room over here, so I'm going to put the square root of 28 over here and see if I can reduce it. And yes, we can. I've got 2 2's. So this right here is 6 plus or minus. These come out, but the 7 stays. Okay. Okay, now we're going to do the same thing that we did up here. I had a number that went into 8, 2, and 10. I also have a number that goes into 6, 2, and 2. Notice that all of these are out of the radical. So if I would have had, instead of this 2 here, okay, if I would have had 6 plus or minus the square root of 2 over 2. Let's say I had that instead where that 2 was inside. This cannot be reduced because you have a 1 outside and you have to reduce 6, 1, and 2. So if it's inside, it's not part of the reducing. It can't be because it's in a radical. So you can only reduce numbers that are outside of a radical. Okay. So 2 goes into all of those. So if I divide this 6 by 2, so I will be dividing each of these by 2. Because I can, because 2 goes into all of them. 6 divided by 2 is 3. 2 divided by 2 is 1. So you just end up with 1 square root of 7. 2 divided by 2 is 1. So it's just over 1. So you don't need to put over 1. Okay. So there's your answer. You cannot simplify this any further. So I'm going to go ahead and put that over 1. Anything over 1 is just that. Okay, now my math lab. Will they accept this right here? I'm not totally sure. If they don't, they may want you to write it out with a comma, where you have 3 plus the square root of 7 and 3 minus the square root of 7. It's really the same thing that we did up here. -4 plus 1 over 5, a -4 minus 1 over 5. Split those in, split that right there, and then we could simplify. Here you can't. But there's your answer. Okay. All right, well, let's go ahead and we're going to try another one. Hopefully this really isn't too bad for you. Let's look at this right here. That's kind of crooked, but okay. 25x squared minus 20x plus 4. Well, okay, way back in chapter 6, I actually been too long, but anyways, before the break, you could have factored this, because remember, we always looked for perfect squares on the ends, and if we had perfect squares on the ends, you could factor it. So I'm going to go ahead and I'm going to try to factor this, but then I'm also going to use the quadratic formula. And then you can see that sometimes factoring can be faster than the quadratic formula. So on this, because 5x times 5x gives you this, and 2 times 2 gives you this, I'm going to see about factoring. Well, I'm going to put a 5x and a 5x. Oh, by the way, it was already set equal to 0, so I didn't need to do that. And then I'm going to put a 2 and a 2 and make them both negative. And then check it using my FOIL method. Well, we get 5x times 5x is 25x squared. -2 times a -2 is a +4. The outside, -10x and a -10x is a -20x. So it does work out, you could factor it. Now this, we have 2 of these, okay? So they're the same. I only need to solve one of them. And we add 2, divide by 5. So x is 2/5. X is called a double root. And it actually has what we call a multiplicity that's even. Because if I were to rewrite this, it would be 5x minus 2 squared. And whenever that's even right there, it means it touches the x-axis. It's a multiplicity. And so this would bounce off the x-axis at 2/5 rather than crossing it at 2/5. But it does touch the x-axis. It's equal to 0 at 2/5. Well, okay, we're done. That's the answer, 2/5. There's only one root. There's only one answer. Because remember, the maximum is 2, but there's sometimes when we only have 1. Okay, and in this case we do, 2/5, because it's a double root. Well, we're going to go through using the quadratic formula, mainly because I want you to practice it and to see a bunch of examples. So I know that x is equal to, yeah, you can see that, plus or minus. So we've got the opposite of b, plus or minus the square root b squared minus 4c, which again you can type into your calculator all at once, over 2a. All right, so now in this problem it cannot be reduced because 25, nothing goes into 25, 20, and 4. So I'm going to put over here, well, I can put it right here. A is 25, B is a -20, and C is 4. Okay, and we're going to go ahead and go through that. So we start off the opposite of the b. Well, b is a negative 20. The opposite of b would be a positive 20. Good. B squared, negative 20 squared. You know, or if you don't want like parentheses, just drop the negative and go 20 squared. All right. But if you put that negative in, you're going to have to use parentheses so that the calculator knows to square the negative as well. So then we have minus 4. The A is 25. And the C is 4. Great. Okay, all over. Don't forget your 2A. 2 times 25. Okay, well, if you were to type this into your calculator, you're going to get 400, and the calculator will take minus 400. So what your calculator will tell you is that's 0. Okay, you come up with a 0 inside the radical. 400 subtract 400. And the square root of 0 is 0. Well, we know that those reduce down, and you get 2/5. Okay, you get 1 root because you had the square root of 0. Same thing, all right? Whether or not you use this method or you realize that you could factor it, you come up with the same thing. And I would not recommend completing the square with that thing, because you'd have to divide everything by 25 and then move that over. So I would use definitely the quadratic formula if you didn't realize that you could factor it. Okay, guys, let's try another one just to see how you're doing. Well, you know, if you were to factor this, 26 is 13 and 2, which doesn't give you 12. So we're just going to go straight to the quadratic formula. And it's already set equal to 0. So we don't have to set it equal to 0, and we haven't been setting it equal to 0. So don't forget, you do need to set it equal to 0. Okay, I'll copy the formula. Looks like we're gonna have lots of room here. Minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, a is going to be 1. There's nothing that goes into all of those, so we'll just leave them. B is going to be 10, the number in front of the x, and C is equal to 26. So now we're going to fill in our formula. We take the opposite of B, so that will be a negative 10. And then we're going to take 10 and square it. I don't need the parentheses, it's not negative. Minus 4 times A times C. Okay, and multiply those together. So then, all over 2a. Let me go ahead and put the 2 times 1. Okay. All right, when we multiply this together, we'll have an opposite of 10. We have a negative 10. This is 100. Subtract, let's see, 4 times 26 gives us 124. Yeah, okay, 404, yep. So, oh, wait a minute, let me double check that. That doesn't, okay, 26 times 4, 104. I'm about to say that looked too high. Okay, 104. All over 2, okay? All right, so we're going to go ahead and subtract inside. Well, I can still go down here. Negative 4. All right, so we have our negative inside. And so when we solve this, we're in the complex number system in this section as well. So we'll have an I here. So when we bring this out, we'll have a minus 10 plus or minus. The square root of 4 is 2, and the negative is an I. So the square root of a negative 4 is 2i. Okay? Square root of a negative 4 is 2i. Let's reduce this down. because 2 goes into all three of these. So we'll have a minus 5 plus or minus I over 1, because I divided each of them by 2, or just a minus 5 plus or minus I. Okay. Now, this, you have a real part and you have your imaginary part of your complex number. Now, it may accept this, my math lab, or you may have to minus 5 minus I, separate it out like that. Okay, all right, either way, it really wasn't too bad. Okay, great. Now, let's go ahead and go through, maybe these might be a little bit more different. We're gonna have to set up our problems here. So we have the quadratic equation is a function, and it's given this right here, f of x equals 3x squared minus 6x minus 4, when, find all x's for which the function, which is this, is equal to 0. So we're going to set our function equal to 0 is what that's asking for. When does the function, which is this, equal 0? Find the x's. And again, we're going to use our quadratic formula. It's already set equal to 0. So we've got a is being equal to 3, b is a negative 6, and c is a negative 4. So we're going to go ahead and put those in. And we come up with, I'll go ahead and write it down. B squared minus 4ac all over 2. We'll take the opposite of b. So b is a negative 6. B is a negative 6. The opposite would be a positive 6. Then we're going to square our b. Use parentheses if you're going to put in that negative. Or you can just put in the positive, because you know when you square it, it's going to be positive. So then we have the minus 4, subtract 4, a is 3, and c is a negative 4. Okay, so when we all over 2 times 3. So we have 6 plus or minus the square root. This is 36. This negative and this negative is going to make this a plus. Okay, but anyways, if we were to take a minus 4 times 3, we get a minus 12. A minus 12 times a negative 4 is a positive 48. Okay, so you have a negative 4 times 3 times a negative 4, and you're going to get a positive 48. So just be aware that when you have the two negatives in multiplication, you'll have that plus. Okay, let's go ahead and let me erase that. We'll have 6 plus or minus. And also, if you just type this in, just into your calculator, it'll spit out the right answer. It'll do the PEMDAS for you. So we come up with, let's see, 84. I guess I don't really need that long of a radical sign. All over 6. And we need to reduce 84 to see if there's 2 of anything in order to pull it out. Okay. And let's see, square root of 84. 4 times 21. 4 is 2 and 2. So we can pull out a 2, but the 21 stays because it's 1, 7, and 1, 3. So the 7 and the 3 have to stay inside. So we'll have 6 plus or minus. These come out. Those stay in. Okay. So now we can reduce this because there's a number that goes into 6, 2, and 6 evenly, and that would be 2. So we'll divide everything by 2. That gives me 3 plus or minus. 2 divided by 2 is 1, square root of 21. 6 divided by 2 is 3. So I divided everything by a 2. All right. Now, can you leave it like that? You cannot reduce those 3's because it has to go into everything in order for you to reduce them. So right now, you can't just make that a 1, okay? That 3 needs to stay there. But there are some options as to how do you write that? What are some different ways of writing that? Now, you could go 3 plus the square root of 21 over 3, 3 minus the square root of 21 over 3. Okay, that's one way of writing those, is to separate them out. Another way is to write it as 3 over 3 plus the square root of 21 over 3, is to separate them out like we had on that one formula. That's a square root, doesn't look like a square root, as being one of the answers, and 3 over 3 minus the square root of 21 over 3. Okay. So now, because they're separated, those can be a 1 plus the square root of 21 over 3. 1 minus the square root of 21 over 3. So there's some different options in writing these. Okay, leave them together. This is what I like. You could separate them just with the plus and minus, or you can write them in parts where you put the 3 under each of the numerator here, and then that would reduce, and you'd have the square root of 21 over 3. All right, so there are these 3 different ways. Okay, perfect. We have a few more to go, and then we'll be done. So in this case, in order to solve it, what we're going to do is we're going to go ahead and multiply everything out using the distributive property, set it equal to 0. We'll see, you know, and we'll go ahead and use the quadratic formula on it. All right, so here, multiplying this out, x squared plus 5x. Can you see that okay? I'm going to have to put a piece of paper underneath it. It's not a very level surface. Okay. So again, using the distributive property, equals, again, the distributive property, 4x minus 2. Let's go ahead and set it equal to 0. Again, try to make sure that your leading coefficient is positive. So we're going to leave it. We're going to bring the 4x and the 2 to the other side. Plus 2, plus 2. So we have x squared. 5x and a minus 4x is a positive 1x. The 2 has to stay by itself. All righty. So let's go ahead and use our quadratic formula to see what the solution to this is going to be. In our quadratic formula, a is going to be a 1, b is going to be a 1. Those are the coefficients in front, and the c will be a 2. And I've seen quite a few students try to put x's with these a, b's, and c's, but they're not. They're only the coefficients in front. Okay, let's write our minus b, our quadratic formula over here. B squared minus 4ac all over 2a. And let's substitute in our numbers into the formula and reduce. We're going to take the opposite of b. And b is a positive 1, so the opposite of b is a negative 1. Now we're going to square the 1. 4 times 1, or a is 1, times c is 2. All over 2 times 1. Okay, so now I'm going to go ahead and figure out what's inside that radical. 1 squared minus 4 times 1 times 2. So we have a minus 1. 1 squared is 1. A negative 4 times 1 is 4 times 2 is 8. Okay. So we still have that minus sign because we only have the one negative that we're multiplying through. So in doing this, we end up with a minus 1 plus or minus the square root of a negative 7 over 2. So we end up with a negative inside of our radical. So automatically we know that we are in the complex number system. We're going to have an imaginary number because we have a negative inside of the radical, that even radical. So we're going to have a -1 plus or minus. Now, if I were to reduce this, the 7 can't come out, but the negative can. So the negative is going to come out as an I, and I like to put them in front so that I know that the I is not under the radical. And then we have the square root of 7 left here. Now, sometimes some people will write this the square root of 7i. You just have to be careful that this does not go over the I. And so it's a lot easier sometimes if you just put it in front. Then you know that the I is not inside the radical. All over 2. All right. Now, this one cannot be reduced. There's not a number that goes into -1, 1, and 2. Okay, but a lot of times they like this written as the real part and then the imaginary part. Okay, so we're going to write that in the form of A plus or minus BI. So we want the real part. The real part is this, plus or minus the imaginary part is this. So I just separated those two into the two separate fractions. So I put the numerator back underneath these separately. Now, normally we go from here, common denominator, to here. Common denominator, you add or subtract the numerators. But a lot of times they may want that separated into the real part and the imaginary part. And they may even want it further, -1/2 plus I square roots of 7 over 2, comma, and a -1/2 plus I square roots of 7 over 2. Notice that whenever I have these plus or minuses, the term that we use for these, sorry, I wrote a plus right there when it's supposed to be a minus. So we have the plus and the minus. These are called conjugates of one another when they match except for the sign in between. So these are conjugates, all right? Whenever you have imaginaries, you'll always have conjugates for solutions, okay? And the same thing with radicals as well. You'll always have the conjugates. Okay, well, let's do a couple more, and hopefully you're catching on. It's really not too bad. Probably maybe the simplifying the radical might be the toughest. Okay, let's go ahead and look at this one right here. I have two functions, f of x and g of x, and I want to know all x's for which f of x is equal to g of x. I'm going to set these two equal to each other and solve it. So this is actually part of chapter 7. So 2 plus 7 over x, that's our f of x. When does f of x equal g of x? All right. Okay, so here's my the equation I'm going to solve, and you need to realize that you can't have a 0, all right? Because a 0 would give you a 0 in the denominator. So this cannot be 0. The x's can't be 0. So when you're solving this, if for some reason, I don't think we are, you would have come up with a 0 as a solution. Make sure you disregard that. So look at your domain when you're given these fraction parts. Okay, how do you solve this? Well, it's really not too bad. What I'm going to do is I'm going to multiply everything by x squared. And the reason I'm going to do that is because x goes into x squared and x squared goes into x squared. Kind of like multiplying by the least common denominator. And it makes this equation so much easier. Is this the only way to do this? No, you could actually use a form of substitution, but it would not be fun. So let's just multiply everything by x squared. So we take x squared times 2. Then we take x squared times this, 7 over x. When I do multiply by the x squared, it cancels, so I get 7x. And then I multiply by my last term by x squared, and they cancel out, so I end up with a 4. So this equation is so much easier to solve than what we had before. And again, just multiply by something that will, that each of these denominators would have gone into, okay? And this one cancels, it leaves you with 1, and that cancels totally. And again, make sure you do that to all 3 of them. All righty. So we have a squared, so we're going to go ahead and set it equal to 0 and use our quadratic formula. Subtract 4. 2x squared plus 7x minus 4 equals 0. We're going to go ahead and use the quadratic formula. I'm kind of thinking that we may have been able to factor this, but let's go ahead and practice the quadratic formula. All right, a equals 1, b equals 7, c equals a negative 4. The coefficients in front of the x squared, the x, and the constant. So we'll have a minus b plus or minus the square root b squared minus 4ac all over 2a. Okay, so now we'll go ahead and substitute in. We'll take the opposite of the b. Opposite of 7 is a negative 7. Square the 7. Oops, I was going to put 49, but that's all right. We have 7 squared minus the 4 times the a, which is 1, times c, which is a negative 4, all over 2a. Oops, and a is 1. Let's put in a 1. Simplifying, minus 7 plus or minus the square root of 49, so, or add 16. Because if you look here, the negative 4 times 1 is a negative 4. That answer times a negative, 2 negatives is going to be a positive. Because a negative times a negative is a positive 16. All over 2. So we have a minus 7 plus or minus the square root of, let's see, 49, 15, 65, all over 2. Okay, and then you need to ask yourself, all right, is there 2 of anything in 65? And there's, well, let's see, 65 divided by 5 comes up with 13. Nope. So this is 5 times 13. And so there's not 2 of anything. So you can just leave it like this. You cannot reduce it any further. They may want you to write it as minus 7 plus the square root of 65 over 2. And a minus 7 minus the square root of 65 over 2. Or you could just leave it like that, because you can't reduce the square root of 65. So the main reason we did this was as a review of how to go from here to here. Just multiply by the highest power. And then when you do that, the highest power should cancel out, and so should the other one reduce. Just kind of a quick review of that one. Okay, all right, let's go on to the next one. And let's see what we've got. Looks like another one that we saw in chapter 7. We want to know when f of x is equal to g of x. Here's our g of x. All right, when does f of x equal g of x? Let me kind of go up here a little bit more. So I set them equal to each other, and to tell you the truth, I'm going to write this one a little bit more level, so that way when I cross multiply, it's a little clearer. Okay, I have 2 fractions equal to each other. There's 2 things you can do. You could multiply both sides by 3 and an x, a 3x. Or, because this is also considered a proportion, because you only have 1 fraction over here equaling 1 fraction over here. When you have a proportion, rather than multiplying by 3x and 3x, you can cross multiply. Okay? And it doesn't matter which one you do first. You could take this x plus 3 times 3 first, and then multiply those. It doesn't matter. let's go ahead and multiply x plus 3 times 3. That's going down this way. Equals. Now you have your equal sign and you multiply, you cross multiply. Okay. So you can cross multiply when you have just a fraction equaling another fraction. So, alrighty. Now let's finish this up. Let's multiply this through. We're going to set it equal to 0. And when I do that, I'm going to move these two over because I want to leave this x squared as positive. So I'm going to keep it here, and I'm going to move these two over. So this gives me a minus 3x, and then a minus 9. Okay. Equals 0. So I have x squared minus 7x minus 9 equaling 0. Okay. All right. Because you get a 0 over here. So now we're going to use a quadratic formula. Go ahead and solve it using the quadratic. A is going to be equal to 1. B is going to be equal to a negative 7. C is going to be equal to a negative 9. And we'll go ahead and go through that. We have a minus B minus 4AC all over 2A. All right, so opposite of B. We're going to take the opposite of the B. B is a negative 7. The opposite of a negative 7 is a positive 7. Negative 7 squared, use parentheses. Subtract 4 times A times C. All over 2 times A. So then we end up with 7 plus or minus the square root of 49. That's what that is. That's going to be plus 36. Negative 4 times 1 is a negative 4. A negative 4 times a negative 9 is a positive 36. All over 2. So this gives us 7 plus or minus the square root of 85. If I did that right, let's see, the 1 is 50, yep, all over 2. All right, can you reduce the square root of 85? Well, 5 goes into it, so if we take 85 divided by 5, we get 17. So this right here is 5 times 117, times a 17, not 117. So this is 5 times 17. You've got one of each, so it cannot be reduced. So therefore, that is your answer, because you can't divide, you can't reduce any of the numbers in front here. You may have to write it 7 plus the square root of 85 over 2, comma, 7 minus the square, oh, 80. Where did I get 82? I don't know. 85. 85 over 2. Okay, either way, they mean the same thing. All right, so just kind of some, kind of some reviews of chapter 7 in solving problems, but on each of them we use the quadratic formula. Even though sometimes it might be easier not to use the quadratic formula, you can, here, this may have been easier if you realized how to factor rather than to go through this. But you can always use the quadratic formula on them all. So, all right, guys, that's it. And I'll go ahead and I'll keep opening up these assignments so that we can finish up. So that was 8-2. We've got 8-3, 5, 6, and 7. And then I think we'll be done. That will be awesome. Okay. Well, again, let me know if you have any questions. We'll see you later, or maybe talk with you later. Bye-bye.